Welcome to this video introduction to R for risk managers. In the past few years, R, which is an open source mathematical and statistical package, has been adopted by a large number of people within the financial community. Risk managers, traders, portfolio managers, researchers, and financial analysts have started to use R as a much cheaper and often more flexible alternative to packages such as MATLAB and others provided by commercial vendors. The reasons for R's popularity are not difficult to see. There are no licensing costs, and there is a large online community supporting the application. So the question arises, where does R fit in for the risk manager? And the answer to that, in my view, is that it complements existing tools and provides additional capabilities of a kind that did not exist before. To provide an example, most risk analysts rely heavily upon Microsoft Excel. They use it to extract and parse data from relational databases holding position information. They pull in pricing data from time series, perform various different analysis, and also often use it as a presentational and graphical tool for generating ad hoc risk reports. How I see R being used in a practical way is as a complement to Excel, to perform additional analysis of a kind that may be very difficult to perform in Excel. This video, being an introduction, assumes that you have never seen R before. We will go through how to download and install R and work through some practical examples of the kind of work that can be done. Specifically, we will go into loading data into R from Excel. We will then also see how to get correlation and covariance matrices, eigenvalues and eigenvectors, perform linear regression and principal component analysis on the data. We will also take a very quick look at how to select random numbers from different distributions and perform a Monte Carlo simulation that models the loss distribution for an operational risk event, all in the next 10 to 15 minutes. So without further ado, let's launch into R. First, you will need to install it. You can download it from the website cran.r-project.org. Distributions are available for Windows, Ubuntu, and Mac OS. The Windows install is pretty straightforward. You download the exe on the website and run it. And then you can launch R by clicking on the icon on your desktop or under your All Programs menu. When you start R, this is what you get to see. The greater than sign that you have here, that is the R prompt. And you can type R commands right here. And let's try a few things out to begin with. For example, let's try adding 5 and 7 together. 5 plus 7, and we get the answer as equal to 12. The one that you see here, that refers to the line number in R's response to you, and 12 itself is the answer. Now let's talk a little bit about variables. You can use any letter or string as a variable at any time that you wish. You don't have to declare it or do anything special before you use a variable. And the way you create a variable is by assigning a value to it. For example, let's make x equal to 5, and we do it this way. X, the assignment symbol, and 5. This means that the value of 5 is stored in the variable x. What this means is, so the assignment sign, you can think of it as an arrow going from 5 to x, which means 5 is getting stored in x. And we can now, in the same way, create another variable, say y. And we now have another variable in the system. We can list all variables in the memory by typing ls. And it shows us that there are two variables, x and y. We can perform operations using the variables that are there. For example, we can do x plus y, and that gives us 12. We can do x by y, and it gives us 0.71, and so on. We can remove variables by using the command rm. And say, for example, we wish to remove the variable x. We remove it by typing in rm and bracket x. At this point, if we do an ls, we will find that the variable x is not listed. Similarly, x plus y will no longer work. In addition to numeric variables of the kind that we have just seen, R also allows matrices and arrays as variables. It also allows for lists, and the most important thing that I'm going to talk about next, data frames. The concept of a data frame is very similar to that of a spreadsheet. with rows and columns. In fact, you could import a range from a spreadsheet into a variable, which is a data frame, and that is exactly what we are going to do next. Consider this spreadsheet. The spreadsheet has price data that I downloaded from Yahoo Finance that I converted to daily log returns for a number of stocks and the S&P 500 index. The first thing I wanted to do was to save the file as a CSV and then pick it up in R. R will load this as a data frame in a variable that I can choose, and we'll call that variable returns. The first thing I do for this spreadsheet is I save it as a CSV file, and I call it returns. All right, the file is now saved in the default directory, and I can go into R and I can pick it up. The default directory for R, i.e. the place where it's going to look for files, can be seen by typing in the command getwd, that stands for get working directory. And in this case, this is the get working directory. I can set the working directory to be something else by using the command setwd, which is to set the working directory. However, since I'm in the right place, I can pick the file up right away by assigning the data frame to a new variable called returns. Read.csv. Yes, it's as simple as that. Returns.csv is the name of the file that I just created in Excel, and I'm going to read that into a variable called return. And here we go. Now, if I wanted to see what the variable now contains, because R really gave me no feedback, is by just typing the name of the variable. And whoop, that was a handful. Let me just reduce the number of rows that it shows up by typing in the command uh, as head, which will show me the first few records so I can see what the data actually looks like. So I have all my data, and one of the things I wanted to see was, did I capture all the rows in the spreadsheet? So the way I can count the number of rows in my variable is by giving the command number of rows and row, and I type in the name of my variable, and I get the answer 756. Let me quickly go back to my spreadsheet and see how many records do I have. All right, so I press end, go back to the end, 757. Given that the first record was really just the headers, I do have 756, which means I have indeed captured all the records that I wanted to. All right, it seems I got everything. Now, and one of the things that I wanted to mention here is the help function in R. Typing a question mark followed by the command takes you to the help screen as follows. So for example, if I wanted to get help on the command and row that I just used, all I will do is type in question mark and row and press enter, and I'll be taken to a screen that gives me the help text for this particular command. And it also gives me some other information as well, including some examples as you can see here. Now that we have the returns data in our variable return, we can now look at the correlation and covariances and do other things that we want to do with this data. But before we do that, let's look at some descriptive statistics for this data. And we can get that very easily by typing in the command summary. In fact, that's a very useful command, as you will see. We will be using this again and again when we do linear regression and principal component analysis as well. So as I type summary, I see this information here. I expanded the screen to be able to see the entire results of the summary command. As you can see, for each of the columns, for S&P 500, for the Oracle stock, Microsoft, 3M, Citibank, and Morgan Stanley, it gives us the minimum, the maximum, the mean and the median, and also the first and third quartiles of the data. In a way, it kind of allows us to judge what the shape of the distribution is like. Notice that it does not do this for the date column because it recognizes that date is really what in our speak is called a factor. It is not really data, it's not numerical information. So it does not do that for the date column. At this point, we are ready to calculate the correlation and the covariance matrices for each of these stocks, the returns of each of these stocks versus each other. So let's just do that, and we can do that quite easily by typing in the command COR for correlation and COV for covariances. So here we go. I type in the command COR return and I expect to get a correlation matrix for all of my stocks in my data frame. And let's see if it works. Unfortunately, it gives me an error. It says X must be numeric. And really what R is complaining about here is that the first column, date, is not a numeric column. So what I need to do is to exclude that column from the calculations. Now there are many ways to select individual columns in a data frame in R. But this just being an introduction, I am going to take the most succinct one, which is essentially a command that says that exclude the first column and include and leave all the others in there. And the way I do that is by typing in returns, which is the correlation matrix for my returns data frame. However, do not include the first column as part of the calculation. And that's what this -1 includes. I could alternatively have written a 2, 3, 4, 5, 6, 7 to say that include all the other columns. Or I could have named all the columns by including their column names, which is MSFT, MMM, C, and so on. But I think this is probably the easiest thing to do for my purposes at this point. So when I do this, I get my correlation matrix. And as you will see, we have a very high degree of correlation amongst most of these stocks. Many of these move together, except for Citibank and Morgan Stanley, that do not have a very high correlation with the rest of the stocks being financial services. Anyway, we can leave the analysis for another lecture, and we can similarly see the covariance. And we don't have to type the entire thing again because we almost typed something very similar in our last command. By pressing the up arrow key, I can get my previous command, I can go back, I can edit it, and I get my covariance matrix here. Since I have my covariance and correlation matrices, and these are positive definite matrices, I can now calculate their eigenvalues and eigenvectors if I need to. I can also perform a principal component analysis, I can do linear regression, and the first thing we will do now is to perform a linear regression on this. Let's try to see if we can predict the price of Oracle using the prices of Microsoft, 3M, Citibank, and Morgan Stanley as an input. And that's a very easy thing for us to do. And the way we do that is by giving the command LM, that stands for linear model. And what we type here is Oracle as a function of, which is given by the sign tilde, MSFT, which is the column name, plus comma, and I need to give it the data source because there could be multiple variables in my environment. Of course, at this point, returns is the only one that I have, but it could be anything else as well. So what I do is I put in the um, data source, which is all uppercase. Um, Variable names are case sensitive, so I have to stick with lowercase here. And I do this, and it gives me the results of the linear regression. Unfortunately, this doesn't seem to be very useful. So what I can do is that I can save the results of my linear regression in a variable, and let's just call it reg, for the sake of simplicity. And in fact, I will not type the entire thing again. I can just bring up the old one, and I can put a variable in here and store it in there, and store the results of the linear regression in there. And I can now look at the summary of my regression here. So what's happening here is that R actually performs a linear regression, does a large number of calculations, but what it shows on the prompt is very little information. If I need to dig into that information, I should store the results of my linear regression in a variable and then dig deeper into it using other commands that are available. And you can see many of these by going into the help screen for LM. What I see here is we see the residuals, the intercepts, the estimate, the standard error, t-value, and the p-value as well. the R square, the adjusted R square, F statistic, and all of the other information that we are used to seeing in any linear regression model that we use with Excel or with any other application. In fact, to get a better understanding of what all of these things are, there is a tutorial available on this URL here, which you might like to see on the riskprep website. In the same way, I can now calculate the eigenvalues and eigenvectors as well. And because the eigenvalues and eigenvectors relate to the correlation matrix, what I will do is I'll bring up the command that I typed in for the correlation, and I will say eigen, go back, close the bracket, and it gives me the eigenvalues and the eigenvectors here. So at this point, it would be useful to introduce the distributions that are available to us in R. R provides functions for nearly all the distributions that we in risk management may probably need to use, at least the most common ones. I provide a full list here, which has been adapted from a source which is indicated here on the screen. The interesting thing here is that when you look at the function, say for example, for the normal distribution, the function is norm, and this needs to be preceded by a letter which could be D, P, Q, or R, depending upon the kind of result that you wish to get. So for example, if you wish to obtain random numbers from a normal distribution, you will use the function R norm. If you want to get the density function, you will use D, norm, and so on. At this point, we are now ready to look at actually using the simulation functionality in R to do something useful. So let us try to model an operational risk event. And what I have here on this slide is a brief description of a very generic methodology for calculating a loss distribution for an operational risk event. We estimate the frequency of the event using a frequency distribution which can be modeled along the lines of the Poisson distribution, and we model the severity using the log normal distribution. We multiply the two and we get the operational risk loss distribution. And the steps to come to the loss distribution are highlighted here on this slide, and you can read them yourself. I'm not going to walk you through them. And what this translates to, interestingly for us, is just a single command in R to do this entire process. So what we have here is RL norm, which means it's a random number generation from the log normal distribution. The first parameter for this function is 100 million, which is the number of simulations we want to see. 2 is the first parameter, which is the mean, and 1.2 is the standard deviation. Similarly, for the second function, we are multiplying it with the Poisson distribution. The first parameter is the number of simulations. Again, it has to be symmetrical. It has to be identical to the one that we took in the previous function, because otherwise, we'll have a mismatch. The number of lines resulting from the two functions will not be equal. So this is also 100 million, and our probability or the arrival rate of the loss event is 10% or 0.1. As you can see, we are able to do 100 million simulations within R, and we are able to store the results, 100 million data points, in a single variable called oprisk here, and then we can perform our calculations on this oprisk variable by calculating the quantiles. And what I'm going to do next is to go to the R console, and I will put these commands in. I'll just copy and paste them to save the time in typing these, and we'll see how much time it takes us to get the results from this simulation. We can now go into the R console and type these commands and see how they work. So the first command, I have it on a notepad window. Let me just cut and paste this from here into the R console. I cut and paste the wrong one. So let me just backspace this one and stick this one in. As you can see, we are going to be simulating this 100 million times, which is a large number of times. So let us press enter, and the operation is not going to be instant because there is a lot of work for R to do here. However, as you will notice, it will take some time, but not a great deal of time, and definitely much beyond the capabilities of Excel. Once the simulation is done, the results will be stored in OpRisk as they have now been, and we are going to look at what the quantiles of this loss distribution look like. And I paste the command here, and it gives me the quantiles. Again, it's going through 100 million records. And as you will notice, on the 90th percentile, there is no loss. And at the 99th percentile, there's a 35 million loss. And the loss just increases very sharply after that, just demonstrating what a long tail this kind of a operational risk loss event has, given the distributional assumptions we have made. This brings us to the end of this introduction to R video tutorial for risk managers. I hope you found it useful. There are extensive resources available on the web for learning R, mostly volunteer driven that don't cost anything. I would encourage you to play, experiment, and enjoy. If you find something particularly useful for the risk management community, do share it on riskprep by posting a comment or an entry in the forum. Thank you.